Sorry about that.
No problem here. So Q is the heat. All right. C is the specific heat. May and sometimes Q is heat or energy. You'll see that as well.
Mm-hmm.
Okay. And then M is the mass, and delta T is the change in temperature. Usually it's T final minus T initial.
Yeah.
Okay. So you actually have all those quantities here. They're all given. In your problem, C is 0.9, your M is 45, and your delta T, your change in temperature is 30 minus 21.5. They're pretty straightforward. They're giving you all the quantities for this equation. Q equals 0.9 times 45 times 8.5.
Are we gonna do like dimensional analysis on this one?
We can, everything does work out. So we'll do that below here. So this is in joules per gram degree C. The mass is in grams and the change in temperature is in degrees C. So you can see that grams cancel with grams, degrees C cancels with degrees C, something like that.
All right.
And you're left with just joules. Is that kind of what you were thinking of?
Yeah, because like the way my teacher showed us in class was like I don't really know how to explain it, but it was like written out like with the letters next to it, and then he like crossed it out like he did.
Sure. Yeah, I mean I think the reason I don't like that is it ends up being too much to see. You kind of lose track of everything. I show them in brackets. You can show them underneath or off to the side. They're kind of the same deal.
All right. Okay. But like if you don't do that, like is just doing the numbers like you would up there, like is that it?
Well, we'll talk about that because some problems will maybe give you the mass in like kilograms, or sometimes the C value is in the wrong units, like it's in kilograms or other
Yeah.
things. So it kind of depends on the problem.
All right. And how do you know like which one to use on which problem? Like which
It,
formula?
it depends on what it's asking for. So that's why the it's so important to know what these stand for. Q is like energy, C is specific heat, M is mass, T is change in temperature.
Okay.
Is that okay?
Yeah, that's all right.
All right. So let's go to number two. Number two,
Wait, so is the answer to number one just like the sum of all of that?
product. You're multiplying these.
Oh, sorry, my bad, my bad.
Yeah, and I mean, I didn't even calculate it. It doesn't matter really. Like it's showing the work is usually enough, but you guess your teacher may want the actual answer. 344.25 joules. Joule is just a unit of energy.
All right, thanks.
All right. All right. An unknown sample of metal has a mass of 15 grams and experiences a temperature change from 22 degrees C to 43 degrees C by absorbing 586 joules of heat. Calculate the specific heat capacity of that metal. So there's two ways to do this. There's starting with the original equation, Q equals MC delta T, kind of the way it's typically written. Or like your teacher's given you the derivations. Do you think you'll be given the derivations?
I think so.
Okay. So this time we're solving for the specific heat capacity, which is C, and the specific heat pass capacity. It's not written very well, but if you solve this equation for C, This is on the bottom. It's really Q divided by M and delta T like that.
All right.
So you have to go back to your equation, I'm sorry, the wording here and figure out what each of these are. And the units sometimes help. So could you tell me what each of those are?
15 is the mass, like M.
Okay. Okay, so M is 15.
Um, the 22 and 43 is delta T.
So delta T ends up being 43 minus 22.
Yeah, and then 586 is the Q, right?
Yes. It's good to write those out. 586, oops, 586 divided by 15 times 21. And then you mentioned this whole thing with dimensional analysis. So we can do that off to the side. Really, that's just a check to see if your units are good. So joules up top, grams on the bottom, and then degrees C is the T. And those are the units of specific heat.
All right. So, would the equation end up looking like 586 over 15 times 43 minus 22? Hello?
Are you seeing my screen?
Yeah, sorry, I
Okay,
couldn't hear
yeah,
you.
just making sure because that yeah, it's here. Delta D is like you said, 43 minus 22, which is 21. That's the number here.
All right.
So yeah, and we do have to calculate that. If you're gonna use a calculator, make sure you put parentheses around the bottom.
All right.
Let me know what you get there for an answer, please.
All right. I got like a really big decimal, like 1.860, like a lot of
Okay.
numbers.
Yep. So let's go up maybe two decimal places, 1.86. And the units are really important. It's a joules per gram degree C. That is the units of specific heat.
All right. And it would be like three significant figures, right?
I mean, your teacher may or may not be emphasizing that at this point. That's usually something from earlier in the course. Um,
My teacher like wants us to do that.
all right, so then you got to look at each of the numbers here. Like you said, there's three significant figures, three significant figures, three significant figures. So yes, your answer has to have three significant figures, and we've got that.
All right. Just wanted to double check.
It's always a good idea to do that.
All right.
Any questions on that before we move on?
No, I don't think so.
All right, so question three, these are gonna be like all the possible variations of the problem. So again, when you read it, you want to figure out like what is it asking for? What is it asking for?
Um, it's asking for like part of the delta T, right? Like the second part of how you find it.
Final temperature, T final. So if you look on your sheet, you have an equation for T final. T final is T initial plus Q divided by Cm. So hopefully you're given those quantities in this problem.
Huh?
Are
So
you given those quantities?
yes,
Yeah, what is the initial temperature?
20, 25.
What is the energy in joules?
3.05 per.
That's the specific heat
Oh,
capacity.
oh, my
That's
bad.
C. That's C.
415 or 15.
Yeah, and then the thing is there's no way to know if your answer is reasonable. Like sometimes you get a number and you're like, I don't know. Um, that's why it's so important to make sure you're putting them in the right place. And then the mass is 55.
All right.
All right, so go ahead and calculate this. Three significant figures for your answer. So you got a calculator handy.
Yeah. I got 27.5.
Very good. What are the units of temperature in this problem?
Joules.
But it's temperature. Temperature is not in joules.
Oh, oh, degrees centigrade.
Degrees Celsius, yeah. So it might be good actually to look at the equations and make sure we know the units for each of them, like what the final answer should be.
Mm.
And we'll do that now. So um, change in temperature, delta T here is in degrees C. P final is degrees C. P initial is degrees C. Mass is in grams. D is the grams. I'm sorry, it's the joules per gram degrees C, and Q is joules.
Okay. Wait, is the C like centigrade or Celsius?
It's Celsius. But centigrade's the same thing. It's like two different ways to say it.
Oh, it is?
Yes.
Oh, I didn't know that. My teacher always said centigrade, so I never like put it
It
together.
depends where they learned it. They just did they obey the convention from which they brought it from. This will also help you to figure out like what you're given and what the final answer should be, as well, like what the units should be. Okay, let's look at number 4.
Mm-hmm. Sorry about any background noise. I don't know if you can hear.
No, no, we're good.
All right, that's good.
All right, so aluminum has a specific heat capacity of 0.9 joules per gram degree centigrade or Celsius. What is that? Is that Q, C, M, delta T? What is that?
Q.
That is Q. No, that is C. Sorry,
Oh,
you let me tie you talked me into that. You got so you got to know this table. Like the units are actually more important than
oh, okay. All right, I see now.
okay, so that's like really, really important to be able to do in these problems. All right, so 75 gram, that's mass. What is the 475J?
Is that Q?
That is Q. Yeah, and in some books they use uppercase. Um, they use uppercase Q. That's what I'm usually used to seeing. But I mean, there's a lot of. And then this is T final. So the initial temperature, it like if you truly are getting the formulas, that's good. We don't have to worry about deriving them, but um, just maybe double check with your instructor.
All
So
right.
you've got 685 minus Q, which is 475 over zero point 0.9 times 75.
Wait, let me do it real quick. I got 678.
Degrees C.
Yeah.
Right. Good job on that. I think that's everything on those two pages.
Mm-hmm.
I know there's another email, some other stuff, chemistry wise.
Yeah.
But any questions on that? Do you want me to look for any more problems on that, or do you?
Um, I feel like pretty good about this, and I think that there's some more in the other email. But like,
Yes.
I don't know for sure, but like, I think that there is.
Yeah, there's a bunch of questions here. Do you want me to start from the beginning?
Uh,
Uh, do you have like certain ones you know for sure you want us to go through?
Not really. Like, those are all practice, so like, I didn't really send them in a particular order, so like, we can just start with whatever.
Okay. I
Just
tend to just do them in order, which means starting with 48.
yes, yeah.
All right, let's do that. All right, it says, okay. All right, so, oh my boy, these are going to be a little bit tough, but we'll be okay. So you're going to need a periodic table if you don't have one. I can also send you to an online one here if you need it. But it says in the explosion of a hydrogen-filled balloon, zero point 0.5 grams of hydrogen reacts with 4 grams of oxygen. How many grams of water vapor are formed? Um,
Um, Actually, can we skip that one? Because I think I might have sent that one by accident. Because like, we didn't go over that in class.
okay.
Like, I think I might have sent that one. Like, I meant to crop it out or something.
All right. So 49, it's kind of the same deal. Like these are, we have to write the equation. So why don't you look at what was, well, I don't know if you know what was sent over. Um, I can just snip these in. So there's that one.
Oh, no, yeah. I don't know why I sent those. We haven't done those. Can we maybe
Here
skip to
is,
like 53, like past that?
okay. So here is the next grouping.
Yeah,
These are like some conversions.
yeah, those are like what we did.
And then the last one, they're conversion word problems.
Yeah, like that's like better.
All right, let's start with joules to calories. So were you given a conversion for joules to calories? Like sometimes teachers give you a reference sheet or something.
Yeah, but can I go grab it? Like I didn't bring.
Yes, yes, go grab it. That way we're using the same ones.
All right, yeah, I'll be right back. Okay, I'm back.
All right. What is 1 calorie equal?
Um, 1 calorie is um. Sorry, I have a lot of. I need to go back to like the beginning.
That's okay. I'll put it here. I'm not trying to be difficult. I'm just trying to
No, it's okay.
get you to
It's like
yeah.
my fault. I wrote them all messy. Mm,
So 12.1 joules. When you're doing a conversion, you put the same unit on the bottom as the top. So it's 4.187.
Okay, I found them.
So you're going to divide, you can see that the joules cancel the joules. And so you're left with calories.
Huh?
So you're going to take this 12.1 and divide it by 4.187.
All right.
And you're going to round to 3 significant figures, please.
Um, I got 2.89
Yes. And what are the units?
calories.
Calories. It's the only one that's left over. Right. Good job on that. Let's look at another. Um, let's, so let's, part B is kilojoules to calories. So the first thing is that we need to convert kilojoules to joules. You always start with the given quantities. Kilojoules to joules. How many kilojoules are in a joule, or how many joules are in a kilojoule? Do you remember?
Yeah, 1,000 joules are in 1 kilojoule.
Very good. Okay, so now we got the right units. You can cross them out as you go or at the end. And then there's a conversion from joules to calorie. It's 4.187 joules in 1 calorie.
All right, so what I multiply like 112 times 1,000, then divide by 4.18.
Exactly, exactly. And you're going to go to 3 significant figures.
Got it. Um, how would you do 3 significant figures if your answer is like in the thousands, like 4 numbers?
Right. So the thing is with your answer, 2 is significant, 6 is significant, 7 is significant. So do you have your 3 significant figures?
Yeah,
Now, does the number round up or down? Does this round up or
uh,
down?
down.
It goes down, so you don't have to change the 7, but it becomes 26700 calories.
All right, got it.
Does that make sense?
Yeah.
Okay. So this one had an extra little conversion in it to get to the right, joules, kilojoules, whatever we got,
Uh-huh.
and you did great on that. Let's look at the next one here. It says 34.5 calories to joules. So you would start with the given amount, 34.5 calories. Calories now goes on the bottom. Whatever's on the top goes on the bottom. And
Uh-huh.
then joules up top here. So
Is
how
it
many calories are in a joule, or how many joules are in a calorie? It's the
4
same
point?
conversion. Yeah.
Wait a minute. Is it 4.187? Because in my notes, like my teacher gave us 4.184.
I mean that there's different ones. I've always used 4.187. It doesn't, you should use what your teacher has
Okay.
been
I don't
using.
know, like the thing about it, he's like kind of weird, so I don't know if he like miswrote it or not, is like just what I wanted to
But
know.
both are correct.
Okay. It's just
You may
like,
wonder why. I don't know. I mean, I've always used 4.187.
all right.
It doesn't really matter. I mean,
All right, got it.
all right, so you got to multiply those two numbers, and then again, you're going to round to 3 decimal places. 3 decimal places.
144
It is 144. And what are the units?
joules.
Joules. Okay, why don't you
Huh.
try the last one there on your own? I'm going to snip it in. Oh, I'm so sorry. well, this one is a little different. Boy. So do you see how it's lowercase c and uppercase c?
Oh, yeah, cows and heat pump.
I really don't know the difference in your textbook. Um, you may want to, we may just want to save that to asking your instructor about.
Okay,
I'm not quite sure.
in my notes it says that like one of like the big C is equal to like 1,000 of the little c.
Yeah, and that's what I'm usually used to. This conversion though that I was giving you, worried now that I didn't give you the right conversion. It's it's so I don't. So it is lowercase c. So some of these were not correct. Um,
Oh,
so like this is it's lowercase c, and so we need to add in here that there are 1,000 CALs and one CAL.
okay. So how would I fix it then?
Well, um, it just means we're dividing by another 1,000 here.
All right. So
So we'll fix these, but
all right, like I said, like it's not an assignment, so like I'm really like not worried about it.
well, yeah, and I mean, so it's a little nuanced. I wouldn't make a big deal out of it, it basically it just changes it moves the decimal over.
All right. So
But you'll see here that it ends up being 0.00289 VAL uppercase CAL.
all right. Okay, that makes sense.
All right. So the next one, kind of same issue here, is that there are 1,000 CALs and one uppercase CAL. And it just moves the decimal in the answer. You're gonna find that it ends up being 26.7 CALs uppercase C.
All right. Got it, got it.
And then this one here, again, I apologize that they didn't notice this. It's such a little nuanced thing.
It's all right.
You have to first go to little CALs. There's one CAL is 1,000 lowercase CALs times one CAL is 4.184 joules.
All right. So for this one, you just multiply straight all the way through and not
Yes,
divide.
exactly. Yes, straight all the way through.
All right. Um, for this one, it's four significant figures, right?
Three, yeah. This 34.5 is the limiting one.
All right. So I got 144,000.
Yeah, very good. All right, so now we can actually do that last one. Probably make more sense. So 128 CALs. So 128 CALs. So actually, this is the most basic one of them all. One CAL is 4.18, I'm sorry, 1.484. No, why am I using the wrong? 4.184 joules.
All right. So 128 times 4.184.
Yep. Three significant figures.
Uh, 535. No, 536.
Yeah, does round up.
Wait, is 4.184 like, why is that not four significant figures?
It is, but you've got three. You go with the limiting significant figure.
What do you mean by that?
Uh, this number only has three significant figures, which is less than the four. So your answer is the one that's the smallest number of significant figures. Even though one is one, it's really 1.00. It goes out as many zeros as you need to get it.
Oh, all right.
So these conversions are as many significant figures as you need, but this is the measured quantity.
All right.
Okay, should we do a few more of these?
Maybe like one or two more, I think would be good.
Okay, all right. So and then we can move to some of these other ones, which are the word problems maybe.
Yeah.
All right, so kilojoules to lowercase calories. Your conversion is that it's 4.184 joules is one lowercase calorie. So you start with the given quantity, and what should we go to first?
Um, to the big calorie.
We can't do that. We can't do that. We can only go
Oh, to joules.
to joules. So how many kilojoules are in a joule, or how many joules are in a kilojoule?
1,000 joules in a kilojoule, right? Oh,
Yes.
yeah, yeah, yeah. All right.
Now we can use that conversion that there is 4.184 joules in 1 calorie. And those cancel lowercase calories. So significant figures, you got 3 in the given one. This is 4 if you need it. This is 4 if you need it, 4 and 4, but you go with the limiting one or the least one.
All right. So I got 3,080.
It's got to be 3 significant figures, though.
Oh, wait, 3,080?
Let me get caught up here. Excuse me. Um, so yes, 3080 is the better one, better answer.
Okay. Is that right?
Yes.
All right.
All right, let me have you do one more on your own here. Let's go ahead and try this on your own
All
and
right.
let me know what you come up with.
Do you think you could maybe just help me get it started?
What is the conversion that we're going to use? Can you go directly from joules to calories, lowercase c?
No. Yes.
Which is it? Yes or no?
Wait. Okay, I think yes.
So you start with the given quantity and you put it on the bottom, the units on the bottom. Can you go to, can you go directly to calories? Yes.
Um, yes.
You seem uncertain. It's the only conversion that we have. 4.184 joules is one lowercase calorie.
All right. Yeah, yeah, yeah. Yeah. Okay, I see now.
All right. So let's move on here to something different.
Oh wait,
There's some,
can you say the answer?
oh,
Is it like
sure.
uh is it 8.15 calories?
Yeah, it's 8.15 calories.
All right.
All right. Um, well, actually, these do take a little bit more. Were you doing anything with kilowatt hours, the joules?
Um, in class we only did like one problem on them. So like probably not.
Okay, let's try I'll just grab a few more of these and have you try them out. Um, Here's a good one.
I got 0.249 calories or cal.
So it's 249 calories times there's 1,000 CALs and one big CAL.
Yeah, I got 0.249 of the big CAL.
Good. All right, let's try another one here.
Hmm. Um, I got 10,516.
So that one of the issues with that is too many significant figures. Five there. What would it be if it was three significant figures?
10,500?
Yes. Okay, now let's take a look here. So 44 kilojoules times 1 kilojoule is 1,000 joules times joules to calories, little calories, 4.184 joules in 1 calorie. Is this your setup here?
Yes.
All right, good job. So it is that there.
Nice.
All right, good job. Um, we have time. I said we could extend the lesson here. Do you feel like you need more things though? Do you need more problems? Do you want any more specific heat problems?
Um, mm, can we just do like one more specific heat and then I think I'll be okay.
Sure. Yeah, let me, I was gonna find, all right, so here we go. So when you read this problem, I want you to decide what variable you're solving for. So I want you to tell me whether you're solving for, um,
What are you
which of the variables basically.
for C?
They're giving you D.
Oh, for Q? I keep getting Q
Yes.
and C confused for some reason.
Very easy to do. Q is energy, sometimes it's called heat. Heat and energy are the same, uh, which is confusing. So this is Q equals C times M times delta T.
All
Go
right.
ahead and see if you can calculate that for us, please.
I got Q is equal to 4,515.
Three significant figures.
Uh, 4,510.
So it should round up. It would be
Oh,
four,
sorry.
4,520. Now you could make the argument that it's two significant figures. I don't know. I mean, you said your teacher's pretty specific about this stuff, so that um, something for you to think about. And that's 78.8 minus 25, but very good. Do you want another one?
Honestly, like I think I feel okay. But can you maybe
There,
just tell me like one more time, like the difference between Q and C, and then like we can be done.
yeah. The main difference, and it goes back to what I was showing you earlier, sorry for all the scrolling here, is that it's the units. Q is energy or heat. C is the specific heat.
Oh, all right. Okay, I guess like the J like throws me off like sometimes.
It still has all right, well, let's go ahead and stop there for today.